The area of a rectangle is 70 centimeters square. So let's draw a rectangle here. Let's say this is our rectangle. So the given area for this rectangle, that is the space occupied by this rectangle, is actually equal to, this space occupied is actually equal to 70 centimeters square. 70 centimeters square. The length is 3 centimeter longer than the width. Find the width of this given rectangle. So whenever you see problems like this, whenever you see word problems in mathematics, first of all, the main strategy here is to convert this English statement into a mathematical equation. And in order to do that, we take the help of variables. For example, in this case, the first statement is very clear. It directly tells us that the area of this rectangle is 70 centimeters square. But the second statement here is kind of important because it relates the dimensions of the given rectangle with the given area. Now you might question how. So let's see. Now it says that the length is 3 centimeter longer than the width. So let us assume, let's say that the width, this width is w centimeters long. Now the length is, this length is 3 centimeter longer than the width. 3 centimeter more than the width. That is, width plus 3 would be equal to length of this rectangle. And this is how you just interpreted the second statement of this equation into a mathematical equation. That is, for this rectangle, this would be our width and the length here would be equal to 3 plus w. Now we know that the area of a rectangle is given as length times width. So let's substitute all the values in this given equation. So area is 70 centimeters square, length is 3 plus w. 3 plus w, and we have assumed width to be w units long. So basically this is the final interpretation of the given statement, given word problem here. Now it's all about calculations and solving this equation, which just has one unknown w. And once we know what w is, we can always go ahead and calculate the length of this rectangle. So let's do that. But why don't you do one thing? Just pause the video here and try to solve this equation on your own. Because till now you have already solved a lot of equations like this. Let's see how we can solve this. So first of all, let us distribute this w on this 3 plus w. So w times w would give us w square. W times 3 would be equal to 3w. So plus 3w, and this is equal to 70. Now let's put all the terms on the same side of equation, and in order to do that, let's subtract 70 from both sides. So this would give us w square plus 3w minus of 70, and this is equal to 0. So now we have a neat quadratic equation in w. So let's solve this. Let's try to solve this further. Just remember, the main strategy part of this question is done. We have converted the given problem into a mathematical statement. Now it's all about calculations. So let's try to solve this further. Let's use factorization to solve this. So basically we are looking for two numbers, p and q. Let's say the numbers are p and q, such that their sum, p plus q, is equal to coefficient of w, that is 3, and their product, that is p times q, is equal to the product of negative 70 and coefficient of w square, which is 1 in this case. So this would be equal to negative 70 times 1, which is actually equal to negative 70. So now we can start thinking in terms of factors of 70. So let's write down the factors of 70. So the factors of 70 would be 1, 2, then 5, then we would have 7, then 10, then we would have 14, 35, and 70. Now we need to pick a pair such that it would satisfy both these conditions, and you are open to use negative and positive symbols as per your requirement. For example, in this case, the product is negative. So we know that one of the values p and q has to be negative. So what pair can we actually pick? So as we can see here, let's say that we picked 7 and 10. And you might question that how can I directly see this? But based on after solving a lot of questions based on factorization, if you would have tried a lot of Khan Academy exercises based on factorization, you would have got used to picking factors now. So if you're finding trouble in doing this, just pause the video here and try to solve few questions based on factorization. So if we would pick 7 and 10, so let's say that we have negative 7 and 10, because negative 7 times 10 is negative 70 and negative 7 plus 10 is positive 3. So this is the value of P and Q that we were looking for. So now let's try to split the middle term in terms of negative 7 and 10. So this would give us W square minus 7W plus of 10W minus of 70, and this is equal to 0. Now from the first two terms we can pull out W as the common factor. So this would be equal to W times W minus 7, and from the last two terms we can actually pick out 10 as the common factor. So let's do that. So positive 10 times W minus 7, and this is equal to 0. Now W minus 7 is the common factor here. So let's pull that out. So this would give us W minus 7 times W plus 10, and this is equal to 0. Now if this is equal to 0, either this factor is equal to 0 or this is equal to 0. So if W minus 7 is equal to 0, W is equal to 7, and if W plus 10 is equal to 0, W is equal to negative 10. But wait, W is actually the width of this given rectangle. But how come the width be negative? It cannot be, right? It has to be a positive value. So that's the reason we would eliminate the value negative 10. We won't consider this. So the only possible value of the width of this rectangle is positive 7. So the width of this rectangle is 7 centimeters long, and if we want to find the length, we can just substitute W as 7 here. So length would be 3 plus 7, that is 10 centimeters. You can now even verify whether your answer is correct or not. 10 times 7 is 70, which is indeed the area of this given rectangle.